Okay, in the last lecture, we went through the introduction, okay, my introduction as well as the introduction of the course, okay, and we talked about we need this course as civil engineers, or we need to know the coding because we deal with numerical methods, okay, so we need, and the calculations which we do, they involve very long calculations, very a large number of steps or large number of data, okay, and I gave the example of planning of a town, or when you are doing it for like number of years and number of students, okay, so there can be large number of data involved, and the calculations are also very long, so if you try to do it manually it will take a lot of time, okay. We discussed some of the areas in which we apply the coding, okay, these are the areas. So I gave the example of each one of them, okay. So for example, when we are finding out the root of the equation, we are trying to find out what? When the equation will become 0, okay. Which value will give the answer equals to 0. Then we have the system of equations to be solved, and we try to solve it manually as well. So this is, we are trying to find out the points where the equations will intersect, okay. Then optimization problem, trying to find out the best value, and I gave the example of your credit hours, okay. So you cannot register 50 credit hours, and you cannot register 3 credit hours as well. They are the value, right? Okay. How much? Normal. How many credit hours you have to register in a normal semester? How many credit hours you have to register in a normal semester? 12, right? Okay. So 12 is the optimum number. If you do less, you will not finish in 4 years. If you do more, you may not be able to handle it. Okay. So optimum is the right value. Curve fitting, looking at the data and seeing if it follows a curve, if it follows a straight line, and so on and so forth. Okay. On the basis of which you can predict what will happen in the future. To find out area under the curve, so area gives you the coverage of the data, how much the data is covering. Then we have the taking the derivative or taking the differentiation, which gives you the change between the two numbers, okay, or the change between the 2 points on the graph, and you can do it in this way. In this way we are taking the whole curve as one, or you can do it using partial differential equation, where we divide the whole curve into small parts, and for each part we do the derivative separately, okay. Then something about using non-computer methods. If you are not using coding or programming, then that's the solution which you will get manually. We call it the analytical solution or exact solution, okay. The things which you do on your calculator, okay, this is called as an exact solution or an analytical solution, which gives you one number. Basically it gives you one exact number. In some cases we draw the graph and try to see from the graph as well, and then we have to use calculators and scales and so on and so forth. I gave you examples of some of the softwares which we use, okay. They can be general purpose or they can be a specialized software, okay. So general purpose, for example, Shama, you have taken 103 before, okay. So which software we were using? MATLAB, right? MATLAB is general purpose or specialized? No, it's general purpose. Okay, we use it, electrical engineers use it, mechanical engineers use it, everybody is using it, right? Okay, what is a specialized software? For example, AutoCAD. Okay, have you taken 160? 160? No, anyways. So when you pass through this course, next semester if you take 160, you will find out that I can only do drawing with AutoCAD. Okay, you cannot find out roots of equation using AutoCAD. Okay, so AutoCAD is only for one purpose, so it is specialized, okay. So MATLAB is a specialized, MATLAB is general purpose. We have another software which we call as Mathematica, okay. I will give you introduction about that as well later on, and you will use it in your projects. Okay, that is also general purpose. And we have another one which is called as Maple. Okay, there are some advantages, disadvantages for each one of them. And then we talked about models. Model meaning an equation. Simple words, a model means an equation. Okay, so you know the equation of energy, right? E equals to mc square, right? Huh? Okay, this is a model. This is a model. Okay, this model gives me how much energy you will have. The mass is this much and the speed of light is this much. Okay, so model gives you something. Okay, now energy is something real, right? Okay, we are using electricity. This is energy, right? Okay, when I'm working, I'm producing or I'm consuming energy, right? Okay, this equation gives you energy in terms of what? What is M? What is M? I just told you. Mass, right? Okay. Is mass the only thing which affects energy? No, there are other things as well. Okay. They are saying energy equals to only these two things. Okay. But does it really make sense that all types of energy are only dependent upon these two? Okay. Where C is what? C is the speed of light. Okay. The speed of light is what? Constant or it changes? The speed of light changes? Who says? It's a constant, right? So we are saying energy only depends upon what? Mass. Is it true? No. Okay. Energy depends upon many things. Well, okay. You go to any electrical engineer or any mechanic who is, who is repairing your AC or your fridge. You tell him energy only depends upon mass, he will laugh at you. Energy depends upon many things. Got my point? So this model is simplifying the real world. Okay. If I give you the actual equation of energy, it will depend upon so many things, this board will not be enough. I will have an equation so long, this board will not be enough. Okay. So model is a simplified version of something which is happening really. Got it? Clear? So model is simplified. Okay, and why do we have the model? Because energy, if you come back here, energy has some effect of mass, right? It also depends upon many things, but energy has an effect of mass as well. Okay, so we are trying to, when you look at a model, you understand the relationship between one and the other parameter. Okay, relationship between one value and the other value. Okay, it is a simplified relationship, but there is a relationship. You got my point? Okay, so this is what I already mentioned. Okay, it's a simplified version because we are not taking everything into account. Okay, and this is so if I put a value of mass here and I get the value of energy, this is called as simulation. Okay, simulation is what? Calculating the values based upon your own data. This is called as what? Simulation. Okay, so you have a model, you have an equation, okay, and you put some values in it, you get the answer. This is, you simulated something. Okay, was it happening actually? No, this was your own value. Okay, so I put a value of mass here, 20 grams.
So this is given for mass or energy is given to calculate it.
Yeah. Okay, so for example, I put mass equals to 20 gram here and I get the value of energy. Okay, do I have any object in the room 20 gram? Maybe, I don't know. I just put a value. Okay, so when you get the answers for your own values, we call it simulation. Okay, clear? Now you may have seen animations, right? Okay, animations, AI animations. Now people are walking, car is moving. Okay, this animation also works on the basis of models. The equation is running in the background. Okay, the equation is running in the background, but instead of values you are looking at the video. This equation will produce what? Value. Those equations, they are connected to the graphics, so those equations are producing videos and pictures. Okay, but those are also simulations. Okay, somebody is putting the values. Okay, there will be three people on the floor and they will be walking and so on. So there is an equation behind that. Okay, and the program is using the equation, but it is not giving you the numbers. It is giving you the picture or the video. Okay, so that is also a form of simulation. Okay, so in this class we will only focus on models. Okay, physical models, not simulations. Only focus on the equations. Okay, so model is an equation. Now you can see equation has two sides, right? An equation has two sides, right hand side, left hand side. Okay. Now, if you normally, what happens if I give you an equation? This equation is for calculating what? Energy. Energy depends upon what? Mass. I can put any value of mass here, right? So mass is independent. Okay. Now which hand is this? Right hand side, right? So the values or the variables on the right hand side are independent. Okay. So you can put any value of those variables which are on the right hand side. Okay. And the left hand side is what we call as dependent. Energy depends upon mass, right? So energy is dependent. Got my point? Okay. In other words, energy is produced because of mass. Energy is produced because of mass. If there is no mass, there is no energy. Got my point? Okay. Can it happen the other way around? Mass is produced because of energy. No. First there should be mass, then energy will be produced. Okay. So now you need to understand the concept of independent and dependent. Independent is which is making the reason, and dependent is the result. There is mass, so there is energy. Mass is the reason, energy is the result. One by one. Okay. So if I change mass, energy will change. Right or wrong? Okay. What about C? Constant. Okay. So it will not change. Okay. So every equation has these three things. A constant. What is this? Mass is what? Independent and dependent. Every equation has these three. Okay. Constant, independent, dependent. Okay. Constant and independent are where? On the right hand side, and the dependent should be on the left hand side. Okay. I can write the equation. Yes, I can write the equation. C square equals to m upon E. Is this equation correct or wrong? Huh? No. If you just look at the equation, forget about dependent and independent. Is this equation correct? It's correct, right? But the relation is not correct. Okay? The speed of light does not depend upon mass. Get the point? It's a constant. Okay? So yeah, I can still get the values, which you do. Okay? Somebody tells you that energy equals to 20 and speed of light is 3 into 9 to power 10 to power something. You can calculate mass, right? So in calculation you can calculate any of these three. Okay, but this is the right relationship. Energy depends upon mass, where speed is a constant. Clear? Okay. So model can be used in different ways, but the correct form of the model is this one, the first one. Okay, so I told you about dependent, independent, and parameters. So this constant is what we call as a parameter. Okay, parameter means constant. Okay, the constant number in the equation is called as a parameter. Getting it? Where is the parameter? The third point. Okay, so C is okay. Now you see here M and C. What are we doing between them? Times, right? We are multiplying them, right? If I do M upon C square, is it correct? If I do M upon C square, is it correct? No. Okay. So if I put the right value of M and if I put the right value of C, but I don't multiply them, I add them or I divide them, I will not get the same answer, right? And I will not get the correct answer. Okay. So just values are not enough. The function is also important. Okay. So this is the fourth thing in a model. Okay. So they are values. Some of these values change. Okay. Like M and E, they are changing, right? The one which is the reason, we call it independent. The one which is on the left hand side, which is the result, is the dependent. Okay. And then we have the parameter, the constant. Okay. And between them we have some function. Add, subtract, multiply, divide. This is called as a forcing function. Okay. Clear? There is no equation without the forcing function. Okay. So all models, all equations have these four things. Okay. Dependent, independent, parameter, and function. Clear? Okay. This is a general way to write the model or the equation. So dependent on the left hand side, everything else on the right hand side. The right hand side will have independent variable, parameter, and the function. Clear? Okay. Yeah. So dependent variable is the thing in which we are interested in, the thing which we want to find out. I want to find out. Okay, the answer is okay. Independent, the thing which will give the answer. Okay, or it will affect my answer. It could be temperature, it could be wind, it could be mass, weight, anything. Okay, parameter, the constant, and forcing function, what we are doing between the values, multiplying, dividing, and so on and so forth. And you can also see that this one is a very simple equation, so there is only one function here, right? Multiply. But there are equations in which there are more than one function. Okay, for example, there could be equation for, I just had it in my mind. Equation to calculate distance, for example. So it will be okay. So if a body is accelerating and the car is accelerating, okay, distance covered by the car will be this equation. Now you can see how many functions we have. 1, 2, 3. So an equation can have more than one forcing function. Okay. How many independent parameters we have? Tell me.
Independent?
Yeah, how many?
2, 3.
3. How many parameters?
2.
1. Okay, so the number can change. You can have 2 independent, 3 independent, 4 independent. Okay, you can have 1 function, 2 function, 3 functions. Similarly, you can have 1 constant, 3 constant, 4 constant. Okay, you know the quadratic equation, right? Second degree equation. Y equals to ax square plus bx plus c. Okay, how many first of all, any equation will have how many dependents? Any equation, look at all these equations. Dependent is always 1. Okay, how many independents? 2. 3. Which 2 and which 3? Three? No. Only independent is x. Only independent is x. When you solve the equation, you find out what? When you do the root of the equation, you find out what? X. Okay. What is A, B, and C? Constants. So 1 independent, 3 parameters. How many forcing functions? 1, 2, 3. Yeah, and okay, clear? So the point is E equals to mc square is very simple because there is only 1 dependent, 1 independent and 1 function. But it can change. Number of independents can change, number of functions can change, number of parameters can change. Okay, so you can see I can make the equation very complicated if I have more functions and more independents and more parameters. Got my point? Okay. Okay. So there are different models which we have already studied, which you guys have already studied in physics. They are written here: conservation of mass, conservation of momentum, conservation of charge, conservation of energy. Which one is written on the board? Energy. Equals to mc square is the last one. Conservation of energy. Okay. Conservation of energy gives you energy, the value of energy. Conservation of charge gives you charge, and so on. Okay. So these are equations which give you these parameters or these values. Okay. What is? Yeah. So any model, any equation can be used as an implicit function like this, or it can be used as a derivative, differential function. Okay, any equation can be like this, implicit, or it can be in the form of a derivative. Okay, so there are 2 ways to show any model, any equation. One is in this way, the other one is in the form of a derivative. Okay, so if I want to show this equation in the form of a derivative, okay, derivative of this equation will be what? dE upon dm, right? What about this one? dy upon dx. And then you know how big the derivative is, what will be. Okay, but this derivative will come from here, right? So I can always do the integral and get the other answer. Okay, this gives me value of y. This gives me what? No. Derivative means what? Whenever we take a derivative or differentiation, what does it tell me? What does it give me? Difference means what? We are calling it what? Differential, right? Differential comes from difference. Difference means what? Difference means what? Difference means? Say it. Minus, right? You take two things and do the minus, right? So you will give you a change. Change. Okay, difference means change. So when you take derivative, you are giving me change in y. What the point? This equation, the implicit function, gives you value of y at a specific value of x. So I will put one value of x, I will get one value of y. This derivative gives me change in y because of x. So derivative or differential gives you change in something. Okay. So this one gives you change in y. This one gives you change in. Got my point? Okay. So different methods to use the model. As I already mentioned, you have something which we call as analytical solution and something which we call as numerical solution. Analytical solution is this one, and this is what we call as numerical solution. The implicit function which gives you one value is called analytical solution. Exact method. This gives you an exact value. Okay, and this one gives you an approximate value. Okay, so this is the differentiation or derivative is used for numerical method. Okay, the simple function is used for analytical method or exact method. Okay, yes. So for analytical method, if the equation is very complicated, then it becomes difficult to solve. Okay, take this equation for example. Okay, what will be the derivative of this equation? Tell me, derivative of this, how much? 2a x, right? Plus b. Anything? Which one is simpler? This is simpler, right? Okay. So which one gives me, or if I am doing analytical method, which one will I use? First one or second one? First one. Analytical method uses the first one, the exact method. Okay, the exact equation. So for analytical method, we try to find out one exact value using the whole equation. So it becomes more complicated. Okay, and now this is a very simple equation. But I told you in real life the equations are not so simple. Okay, it can be very difficult. Okay, I will show you an example later on. Just to give you an idea. So analytical method, although it makes sense, it is direct. You use the equation directly, no derivative, no differentiation. But sometimes because of the size of the equation or because of the type of the equation, it is not possible to apply it. Okay, so you have to keep this in mind. On the other hand, numerical method, we will be producing an approximate result. So this one will give you an approximate result. So accuracy is a little bit low. Analytical method, accuracy is higher. Numerical method, the accuracy is a little bit low. Okay, but in numerical method, you can increase the accuracy by increasing your calculation time. Okay, so for example, if I run the code for 10 seconds, it will give me an answer. If I run the same code for 20 seconds, the time is increased, right? Accuracy is also supposed to increase. Okay, but it is not. If I run the code for 10 seconds, it will not give me an answer. It will still give me an answer, but that answer will not be so accurate. Get my point? Okay. In exact method, there is no such thing like this. Either you will get the answer or don't get the answer. Tell it. Okay. So you tell me I have a value of y, or I don't have a value of y. Simple. But in the numerical method, you can tell me yes, I have a value of dy by dx, but its accuracy is low. Give me more time, I will give you more accurate answer. But if you cannot give me more time, this is your value, take it. Get my point? Okay. Have you taken 131? No. Okay. Have you done physics or chemistry experiments? You have taken physics and chemistry, right? So you go to the lab and do the experiments? Okay. Some of the experiments you do it once. Some experiments you do it 3-4 times. You repeat, right? Okay. Which answer is more accurate? With repetition or without repetition? With repetition more accurate, right? Same principle applies here. But if you don't repeat, do you have a value or not? You still have a value, right? But that value is not so accurate. Same principle for numerical method. You have a value, but the accuracy is low. Okay. For example, I don't know if you have seen this. This is a sport, right? They tie their feet and then they jump off and they hang from the bridge or something. It's a sport. They call it bungee jumping. Okay. So this is the equation. Okay. To calculate the velocity of this guy who is falling. Okay. So v is the velocity, c is a constant, m is the mass, and g is what? What is g? Gravity, right? G is gravity. Okay. So now in this equation, tell me first of all, is this an implicit function or is it the derivative? Derivative, right? Okay. Derivative of what? Velocity. With respect to what? Time. Okay. So change in velocity with respect to time. Okay. Now is this for analytical or numerical? You have two methods, right? Analytical and numerical. Which one we can apply on this equation? Analytical or numerical? Analytical or numerical? Analytical gives you exact value. It's numerical. It gives you the change. Okay, so it's an approximate value. Okay, so they want to find out how the velocity will change for this guy with respect to time. So if he is doing this bungee jumping for 2 seconds, what will be his velocity? If he is doing it for 4 seconds, what will be his velocity? Okay, so this is this is the numerical method. And okay, in this equation you can see now dependent is velocity, independent is time. The mass of the guy doesn't change, right? He's the same guy. So mass is constant, gravity is constant, parameter, yes. Okay, and coefficient Ct is also a coefficient, so it's also constant. The only thing changing here is time. Okay, so and the function you can see, we have a negative function, we have a division, we have a multiplication. So all of these are forcing functions. This is the analytical equation, the exact equation. Velocity equals to this. One answer. Okay. So if you want the analytical solution, you will use this equation and plot it. Plot the graph. Okay. T on the x-axis, v on the y-axis. You put different values of t, you get different answers for v, and you plot it. Okay. Somebody asks you what is the velocity at 4 seconds, you will go to the graph. Okay. What is the velocity at 6 seconds? What is the final velocity? The last one. Okay. So at every point you have an exact value, analytical solution. But to do this, now you know that you have to do the whole graph. Okay. Or you will wait for the you will wait for the value of time and you will put the value of time and you get the value of velocity. This is the analytical method, okay, where you have to know the whole equation. And this is the numerical method. In the numerical method, we are using the derivative, right? And derivative means what? You have the change in velocity with respect to change in time. Okay, so you can so you will give me a value of velocity, initial value of velocity, initial value of time, and you will ask me how much will be the value of velocity after 2 seconds more. Okay, and I will give you an answer. Okay, now if you want, so you can see this is a curve, right? When you plot the curve, if I take the slope, if I take the slope here, is it the same slope as this point? No, it changes, right? The slope is changing. Okay, so this is how you can make the numerical method more or less accurate. The slope is the change, right? Derivative is the change. Okay, meaning the slope. Okay, so if you take the whole curve as one slope, it will not be accurate, right? The whole curve does not have one slope. Okay, so I can break the curve into intervals. Okay, so I was telling you that if you increase the time of your code, running the code, your accuracy will increase, right? Okay, so how it will increase in this example? You have to break your curve into smaller parts. Okay, you can break it, and so this is time, right? You can break it by taking delta t equals to 2 seconds. Okay, so for example, from here to here, you have total 10 seconds. Now, if you break it into 2 seconds, 2, 2, 2, 2, you will have 5 intervals, right? You will have 5 intervals. If you break it into 1 second, the total is 10, and you break it into 1 second, how many intervals you will have? 10 intervals. So intervals will increase, accuracy will also increase. Okay, but now you need more time to process, right? Because you are processing 5, now you are processing 10. Okay, so this is how the accuracy is supposed to increase. Okay, this is what they are showing here. So if you take the whole curve and you just find out one slope, it will be very fast, but it will not be accurate. Okay, but if you do it like this, break it into intervals, it will need more time, but it will be more accurate. So every interval will have a different slope. Okay, and so on and so forth. Any questions up till here? Clear? Okay. We needed this, or you needed this background because we are civil engineers, right? Okay. So when we apply the programming and the coding, we must know what we are doing. Okay. Like last semester, I was teaching a course and I asked the students to another course, not this one. So I asked a student, you have a program which can do anything, your choice. So somebody came with a program which can take a number and tell if it is negative or positive. Do you need a program for this? You don't need a program for this, right? Okay, so when I told them you need to have a program which can do something for civil engineers, they say we don't know. Okay, so even ChatGPT can give you the program. Okay, I'll show you even in MATLAB or even in other programming languages. Okay, even if you don't go to ChatGPT, every program, most of the programs have their own help chat. So you can write your question in the chat and it will give you, okay, this is your program. So having a program is very easy, but the chat will not help you what type of program you want. The steps or what is a dependent, what is independent, what is a constant. The program will not tell you this. Yes. Okay. So like I was saying, if you don't tell the program E equals to mc square, you tell the program c square equals to m upon E, it will solve it for this one. But what is the correct equation? Okay, because here the dependent and dependent are switched. Okay, so you are getting the right answer, but your concept is wrong. You are trying to calculate a constant. Do you need to calculate a constant? Okay, but if you put this equation in the program, it will give you an answer. Okay, you need to know what you should put, this one or this one. Do I need a constant or do I need energy? Got it? Okay, so this is why these concepts are very important. Okay.